Students will derive prism formula today. Last time we discussed about prism. What is a prism and in what situation you can call a particular thing as a prism. Because prism is a material is okay. It consists of those two triangular faces and three rectangular faces that we discussed. But also we must also know that in case of a slab, in case of a glass slab, that also can act as prism. So that we discussed in our last video. Today we'll derive the expression for prism. Okay, so prism formula, derivation. Now, first of all, we'll draw a prism, and then we'll derive the prism formula. Let us draw a prism. This is the principal section of the prism. So the prism is like this, this type of shape. Okay, like this. So this is the triangular face. This one is also the triangular face. This is a rectangular. This is rectangular. The base is also rectangular. So as you can see only this section, this part. Okay, so this is triangular in shape. If I see through this side, I will also see the triangle. So this is what I have done. So the prism, I am actually viewing this prism from this side. So therefore, these two sides are, this is the inclined planes, and these are the refracting faces of the prism. So here the light will incident and allow the light to pass through this side, and it will undergo refraction at this face, and then it will move forward, and again it gets refracted at this end. So it will undergo refraction two times. One when this prism is suspended in air, so the ray will move. Suppose the light is white light. The white light will move from air and incident at the glass surface of the prism. So there will be a refraction here. Again, as the light moves in the glass and again it comes out from this side, it will find air. So there is another medium. So therefore it will undergo refraction two times. Now, let us say this is the incident ray. In the absence of this prism, this is a prism. This is called ABC. Suppose this is P. This point is a Q. Okay, I will call this as Q, and this point is R, and it comes out like that. Yes. So PQRS, the ray goes like that. That's the path followed. A is obviously the angle of the prism. Now, this is the point where refraction is taking place, and this is also the point where the refraction is taking place. We'll draw a normal at these two faces. This is the normal here, and that is the normal there. Okay, this is suppose N, and this is suppose M, and the meet at suppose point is T. This is the point where they meet. Now, if you look at this A, Q, T, M, this is a cyclic quadrilateral. This is a cyclic quadrilateral. Now, this angle is called I, angle of incidence. This is the normal, and this is the ray which is refracted. So therefore, this is R1, angle of refraction at the first face. Similarly, this angle, what is R? This angle is R2. R2 is this angle between the ray and the normal. Finally, it comes out. This is the emergent ray, and makes an angle of say E. Now, I will first write everything that we have considered here. ABC is a prism, so I'll write everything in another page. I'll write. Okay, I'll take one more sheet. ABC is the principal section of prism. Then PQ is the incident ray. What I'm doing is this: PQ is the incident ray, QR is the refracted ray, and RS is the emergent ray. I is the angle of incidence, R1 is the angle of refraction, R2 is the angle of incident for this phase, and this is the angle of emergence. QR is emergent ray because it is coming out of the surface, and I is angle of incidence at the first surface. First surface means which side? AV. This one. Here the R1 is the angle of refraction. R2 second surface, that is AC. Angle of emergence. This NT and MT are the normals, they meet at T. Now, if in the absence of this prism, this ray would have gone straight like that. But finally, it followed this path. So the angle between the incident ray and the final emergent ray, that is this angle, this you can get after so many reflections or so many refractions, whatever is the case may be. You draw the first line and see the last line, that means first ray and the last ray, the final direction of the ray. The angle between that is called angle of deviation. So therefore this is the initial direction, this is the final direction. So the angle is this is called angle of deviation, delta. So now this point is suppose O. So when we extend this PQ in the forward direction and RS in the backward direction, they meet at O, and the angle between this line and this line is delta, that is known as angle of deviation. So these are the things that we are using. Okay. Now we'll derive that. Basically the derivation is to find the refractive index of the material of the prism. That means, you see here, this is what we have first drawn. Prism formula basically means what? Prism formula. What is the prism formula? In prism formula, we will derive refractive index of the prism with respect to air, because this is suspended in air. This side air, this side air, this is glass. So the prism, that is a glass which is made up of glass, is suspended in air. So this formula gives you to find the refractive index of the glass, that is the material of the prism, and that is found using Snell's law, that is sin I upon sin r. This is sin I upon sin r. So in sin I upon sin r, we don't want to write I or don't want to write r, because which I you will take? if I say that okay, this eye, then which are, this is also angle of refraction, this is also angle of refraction, because this is entering and coming out, this is refraction, this is the angle of refraction, though we call it angle of emergence, but the ray is refracted at this face also. So which eye? I am writing eye here means this eye, and then which R you will take. So therefore, this refractive index, which is sin I upon sin R, which is Snell's law, here I is to be replaced, and here R is to be replaced with a known quantity. Which quantity? You have to write these angles in terms of angle of prism, because the prism is there, its angle is fixed. Then you have to find the deviation angle in terms of this delta, that we will also find. So in terms of that, we have to write this I and R. How to do that? Now let us proceed to solve this. That means we are going to establish the relations between this I and the angle of the prism and this angle. How we will do that? So now we'll consider this triangle OQR. Okay, we'll consider this triangle OQR. As you can see clearly that this angle, which angle? This angle and this angle. These are the two interior angles, remote interior angles, and this is the exterior angle of this triangle. According to exterior angle or interior angle formula, that the exterior angle is the sum of the two remote interior angles. So this triangle is like this: O, Q, R, and this is extended. This is the extension. Okay. So this angle is delta. This point is O. This is Q. This is R. Therefore, this is the exterior angle and these are the two remote interior angles. So delta must be equal to the sum of these two. If this is alpha, this is beta, then delta is alpha plus beta. This is the theorem. Now, what is this angle? This angle is this full angle minus this angle, because this total angle is, this angle is total angle minus this angle. What is this total angle? As you can see here, this line and this line, these are the opposite angles. This is I, so therefore this will be I. So this full angle is I. From I you subtract R1. From I, because this is I, the whole thing will be I. O, N, Q, P is I. So therefore O, Q, T is also I. Opposite angles. So if this is I subtract this R1, so this is left with I minus R1. So this is the angle. Similarly, what will be this angle? This angle will be the full angle minus this R2 angle. This angle I'll subtract this. This full angle is E, because this is E, so therefore this angle is E. So therefore this will be E minus R2. The same process. The full angle is E. I subtract R2, so this will be E minus R2. So therefore, from the triangle O, Q, and R, this is what we are going to write. What we are doing is, this delta is sum of these two remote interior angles, which is I minus R1 and E minus R2. Okay. So this delta will be I plus E. I keep these two together, and minus, I take minus common, so this is R1 plus R2. Or I can write, okay, this is we can keep as equation number 1. Okay. Now I will see the diagram again, and I will choose some other triangle or any other relations. So this triangle we have already taken and got the relation. Let us consider this triangle. This triangle QTR. Sum of three angles is 180 degree in a triangle. So therefore, R1 plus R2 plus this angle is 180 degree. R1 plus R2 plus angle T is 180. So from triangle QRT, I can write that R1 plus R2 is your angle T. Okay, this is your T. Plus T equals to 180 degree. Some correction. The sum of three angles is 180 degree. Okay. Now I write that R1 plus R2 from here is 180 minus T. The angle I am not writing here, 180 minus T. This is equation number 2. So what I have done, these two angles plus this angle, T angle, I call this angle T. So sum of three angles, three angles is 180 degree. Okay. Now we will consider this AQTR, this AQTRA, this quadrilateral having four sides. These four sides quadrilateral AQTR. What we'll get? The sum of four angles. This A, Q, T, and R full is 360 degree. Is always 360 degree. Is always 360 degree, and out of which this angle and this angle is 90, because this is the surface and this is the normal. Normal means this angle is 90, so therefore this angle also will be 90. So from this quadrilateral, this angle is also 90. This angle is also 90 because this is surface, this is normal, so this will be 90. From 90, 90, 180 is gone. So therefore, this plus this should be 180. So from quadrilateral AQTR, AQTRA, I will write that A plus T is 180 degree. This is what we write. Now you can see we have got three equations. One is this, second one is this, and third one is this. Now we'll relate these three equations and eliminate those unnecessary variables, like here T is not required, so T I will replace. Now you can see here it is this equation, this T can be brought to this right side of the equation, so therefore this will be written as A equals to 180 minus T. This I get right. Okay, so A is 180 minus T. This is the equation number 3. Now if you compare this 2 and 3, you'll see that this A is R1 plus R2. Okay, this R1 plus R2 and this A will be same because right hand side is same. So I write A is R1 plus R2, and that is a new equation, and that R1 plus R2, which is A, is substituted in equation 1. So this therefore will become A. Okay, that is what we are going to write now. So I'll write that from equation 2 and 3, okay, A is R1 plus R2. This is put in equation 1. Okay, so what was equation 1? The delta equals to, equation 1 is this, delta equals to this. This is the equation. Okay, now this R1 plus R2, here is also R1 plus R2, I will write A. So this will become this, putting this value in equation, I will have this equation. So therefore I will write A plus delta is I plus E. Okay, A plus delta is I plus E. So this is another equation I'll call equation number 5. This is a very important equation, so I'll just put it in a box. Very important equation, that I plus E is A plus delta. Now we have to study about this delta, how this delta behaves with the incident ray. As the angle of incidence at the first phase, when first time refraction takes place, this angle is I. As you change I, keep on increasing I, what happens to the angle of deviation delta? It is found that as you increase, the angle of deviation decreases. Angle of deviation will decrease and attains a minimum value. What is the meaning of that? What I am saying is that when you see the picture, this is the prism, this is the incident ray, this is the normal, this is the angle of incidence. So the angle of incidence is now this angle. If the ray strikes at this line, the angle of incidence will be reduced. So the angle in this case also, if the angle of incidence is this direction along the normal, then the angle of incidence is 0. Okay, if the ray strikes normally to the surface, that means it moves along the normal, then angle is 0. This angle will be 0 because this line will be on this line NQ. Now it is like this, so creating some angle. Now if this moves closer and closer towards N, that angle I will reduce to 0. So when this ray approaches this normal, I tends to 0. When this approaches this base, this VQ, I tends to 90. So I tends to 0 when PQ approaches normal, and I tends to pi by 2 when PQ ray tends to towards this BQ, this side. Okay, that means angle of incidence has maximum of 90 degree and minimum of 0 degree. You cannot have angle of incidence greater than 90 degree or less than 0 degree. That is what you see from here. If I plot a graph of angle of incidence with respect to the angle of deviation, as I move the ray PQ from this line, correspondingly gradually I will increase the angle of incidence like this. So as this I increases, what happens to delta? So this is what practically we have to do and see what happens to the delta. That means what happens to this delta angle of deviation. Experimental observation says that, so this far we have done, we'll come back to this later on. So it has been found the graph of the deviation angle versus the angle of incidence. I will consider this, and this is your x-axis, which I will take angle of incidence, and here I will take the delta angle of deviation in y directions. This is the origin, coordinate 0, 0. So when the ray is moving like this, the PQ is along this line, I is 0. So I will avoid 0 because this will go straight without any deviation. Because this is a case of normal incidence, we know that in case of normal incidence there is no deviation in the path of the ray. Though there is still refraction, there is no deviation. So if is the case, then I will say this line and this line and then extend it. That deviation will be more or less nearly equals to 0. So that means I'll start from somewhere here with certain angle of incident, not 0. The graph will start from here. It will have very high value of deviation. The deviation will be maximum as this I is towards 0. So for this case, it is the maximum. It's very high at lower angle of incidence. Gradually, as the angle increases, this value drops to this point. Again, I increase, this value drop to this point. Again, I increase, this value drop to this point. Again, I increase, this value drop to this point, like that. So it decreases as this angle of incidence increases, the deviation decreases, and the shape that we have seen is something like that. This is how the graph looks like. This is the minimum value of delta. This is delta line, and in this graph you can see that the delta you can achieve minimum is this, because below this there is no line, no curve is there below this. So this is the curve. At any point you will have delta which is greater than this point, this value. So this delta here is called delta minimum. This I is a special I, and this deviation is minimum. Deviation becomes minimum when the angle of incidence is equal to the angle of emergence. This is the condition where this will become minimum. So if I show you the graph of the diagram, you can see here when this I becomes equals to E, I becomes equals to E under this condition only. Okay, under this condition only, the deviation delta becomes minimum. This is the thing. So this condition, if you put an equation, so I becomes E. It is found from the experiment that when I is E implies delta is delta minimum. Delta minimum. If I, this I, whatever angle it is, if it is more than that, I and E will not match. If it is less than that, I or E will not match. That means for this surface where the ray is striking the surface for refraction, I will strike at different angles, different angle of incidence. At a particular angle of incidence, that will match with the angle of emergence. In other cases, it will not match with the angle of emergence. So the deviation will not be minimum. When at a particular angle of incidence, at a particular angle of refraction, these two angles will match, and there you will see the deviation is minimum. So when I and E, the angle of incidence and the angle of emergence are same, then only this attains minimum value. Putting this condition in the last equation that we obtained, last equation, the equation number 5 is I plus E is A plus delta. I will rewrite the equation. The equation 5 is I plus E A plus delta. Substitute in equation 5 this condition I or E are same, so I will replace E as I. I will replace E as I over here, so this is I plus I, because I and E are same. Why I? Why shouldn't I write I E here? Because in prism formula, in the case of Snell's law, mu is sin I upon sin R, we are going to replace I, not E. So therefore, this has to be in terms of I. Okay, now this is A plus delta. Now this delta is delta minimum, so write delta minimum. From here, what you are getting? From here, we are getting 2I A plus delta m. Now 2I is A plus delta m. 2I is A plus delta m. So what will be I? I will be this is what we got finally. We were looking for this I in mu of sin I upon sin I. We are supposed to remove this I with this value. Similarly, A should be replaced in some what terms. So this is what first we got this here. Okay, this is equation. This is okay. Now think of the earlier equations. It has been found that when I is E, R1 and R2 also become same. That means when this I is equal to E, this R1 and this R2 are same at minimum angle of deviation. This ray which goes inside the prism is parallel to the base. When minimum deviation occurs, the ray QR which is through the prism is always parallel to the base. If it is so, then this R1 and this R2 are same. So at minimum deviation of prism, R1 and R2 are same. I will call this as if these are same, I'll call it R. And I'll put this in equation. One equation that we have derived earlier is R1 plus R2, equation number 4. We know that A equals to R1 plus R2. That was equation number 4. So from here, R1 and R2 is R. So I'll substitute this here. So this becomes R. This becomes R. Because this is also R. This is also R. So 2R. R plus R. 2R is A. So R is A divided by 2. This is. So now you got the answer. I will be A plus delta M by 2. R will be A by 2. So finally, we are successful in replacing I and delta R in terms of A and delta M. So that is the final answer. So what is that? Then angular prism. Angular prism is A. So prism formula from Snell's law, refractive index of glass with respect to water, that is the refractive index of the prism material, is sin I upon sin R. And what I you got here? I is sin of A plus delta M divided by 2 divided by sin R. Sin what is sin R? Sin A by 2. This formula is called prism formula. Okay, this is called as prism formula. Now, this angle. Now let us discuss a little bit about the things that were done. This derivation could have been also be this obtained in different approach also. That this angle is 90, so therefore this angle will be 90, and this angle is R1. This angle will be 90 minus R1. This angle will be 90 minus R2. This angle is A. So the sum of three angles should also be 180. What is the meaning of that? Let us discuss a little more about this. If I consider the triangle AQR, we have derived the prism formula. Now, in this triangle also, if you think of this triangle A, Q, and R, this angle, this triangle I will consider and get one relation, A plus this angle. This total angle is 90 degree, and out of this I will subtract this R1. So this will be 90 minus R1. So this angle A plus this angle 90 minus R1 plus this angle which is 90 minus R2 is also 180 degree. this angle plus this angle plus this angle. This angle comes out to be 90 minus R1. This angle comes out to be 90 minus R2, and this angle is A. So finally, we will get this. So this 90 and 90 will cancel, 180 cancel out, and A is R1 plus R2. This way also you can get A is R1 plus R2, but we approach in a different way. You can approach in any way, but that is the final expression. The final expression we got was this expression that u is sine I plus I, write A plus delta m by 2 divided by sine A by 2. This is the present formula. Okay, thank you.